Hi everyone, I am Madam Rosmaya. Welcome to my YouTube channel. In this video, we are going to discuss on energy of a satellite. First of all, we are going to derive gravitational potential energy of a satellite. The general expression for a gravitational potential energy arises from the law of gravity and is equal to the work done against gravity to bring a mass to a given point in space. From definition of the work equals to F/ds, so work is equals to the change in potential energy du, then equals to F/dx. So from the diagram here, refer to the object from infinity. So it is brought to a distance to a point P, where the distance of the object to the Earth is given by x, and then the distance at point P to the Earth is r. So the F is from the gravitational force equals to negative gm, mass of the object or the satellite, times the mass of the Earth divided by the x squared. So this distance. Then we take the integral both sides, and the distance is from infinity. So therefore, from gravitational force, F equals to negative gmm per r squared. The force approaches zero for large distances, and it makes sense to choose the zero of gravitational potential energy at an infinite distance away. So we can write here 0 to u. U is a potential gravitational potential energy at point P. And then the distance here we can put infinity to r. So r is the distance from point P to the center of the Earth. So we use integration rule. We get this on the left side equals to u, and on the right side x bring up become to the power of negative 2. Then using integration rule, so we plus 1 and per negative 2 plus 1. Then we get in the bracket here becomes gmm per x. Okay, and then we substitute r and infinity into the equation. So we get u equals to negative gmm per r. So this is the gravitational potential energy of a satellite. Okay, next we are going to derive kinetic energy of a satellite. A satellite of mass m orbits the Earth such that the radius of the circular orbit is r. So using centripetal force, where it is provided by gravitational force, so we can write mv squared per r. This is centripetal force equals to gravitational force gmm per r squared. So again here m is the mass of a satellite, and the capital letter M is a mass of a planet. So we can cancel out r. Then we to relate with the kinetic energy, where kinetic energy equals to half mv squared. So we multiply both sides of the equation by half. So we get half mv squared equals to half gmm per r. Then we can substitute the kinetic energy using symbol K equals to half mv squared into the equation here. So we get K equals to gmm per 2r. So this is the kinetic energy of a satellite. Okay, so we've done for the kinetic energy and gravitational potential energy. So we are going to derive the total energy of a satellite. So total energy of the satellite is equals to the gravitational potential energy plus the kinetic energy of the satellite. So from the previous slide, we get U equals to gmm per r, and the kinetic energy K equals to gmm per 2r. So we substitute these two values into the total energy. Then we simplify the equations, become total energy equals to negative GMM per 2R. Okay? Because the denominator here is 2R, so here we times 2, so the numerator here also times 2, so negative 2 plus 1 is negative 1, so we get negative 1 GMM per 2R. So this is the total energy of a satellite. So next we are going to sketch a graph of gravitational potential energy, kinetic energy and total energy against the R. So y-axis is energy, x-axis is the distance to the center of the earth. So for total energy, the E we sketch like this, because it is inversely, E is inversely to R. Then the graph is decreasing value, and R here is the guidance line for on the surface of the earth, because R, capital letter R, is radius of the earth. Then for the kinetic energy, the graph is positive, so it is symmetrical with the total energy, because their equation is almost the same except for the sign, negative, and K is positive. So when we plot the graph, so make sure K and E are symmetrical to each other. Then for the gravitational potential energy, which is equals to negative GMM per R, so because of negative, we plot or sketch at the negative side. Also it's decreasing value, because U is inversely proportional to R. So we draw the graph down lower than the E, total energy. Okay, that's all for the video. If you like my video, please subscribe. Thank you for watching.